We're going to be examining conservation of energy laws as they apply to collisions. So we're going to be conducting our collisions lab here with the PHET simulation, where we have two bodies that will collide with each other and with the sides of the system here. Okay, you're going to be looking at a data table that looks much like this. And so the mass of the balls and their velocities are already prescribed for you, and you can actually set them from within this simulation. Now, the first thing, we're going to be dealing with one dimension only. And let's just reset this, go back to one dimension. Very good. Now, in order to fill in our data, we need to go to the More Data button here. Okay, now just be careful because the table you are reading and the table that's on this simulation don't match up very well. I know that both of my masses here are 1 kilogram, and so we're going to be dealing with 1 kilogram bodies, 1 and 1. And we aren't so concerned with the x and y position of them, at least not in this lab. We are, however, concerned with the velocities. Now, because it's one-dimensional, the y velocities are already set to 0. We don't worry about them. However, our x velocities are prescribed in this table, and they are 0.5 and -1. So here we go. I'm going to fill this in. This is 0.5, and this one is -1. Okay, now we're going to get ready to run the simulation, and we want to pause it before things get out of hand and start to run into walls. And so we'll hit play, and now we're going to hit pause, and we're going to complete our data table because our velocities have changed. Okay, this table also includes sections for calculating the momentum and the total momentum and the kinetic energy and the total kinetic energy, both before and after the collision. As well, make sure you do what I did not do, and that is turn this into a completely inelastic collision. And so really, it should look a whole lot more like this when they collide. Bang, that's inelastic, they stick together. Okay, fill that in.